嗯，
您解锁，请取出话筒。
你那天去哪里上课？那天去哪里上课？你那天你讲有补课那天啊？你去到课室了吗？哪一间课？哦，反正来那个 venue 你在那里啊？怎么你会想到 A8109？我们是定那个地方的名字。哦，你说那个日期没有看到 F1G09的？哎，是吗？09。哦，我们平时都是在 A5G0。你 message 的时候吓到我，所以我今天怎么没有去上课？Uh, okay. How about we start first? We will make announcement for midterm later, and so today we're gonna have quiz. So please call your friend to come to the lecture. Okay. Later on we'll have quiz. And then another thing is okay. We will check revision assignment later. One of you already submitted, so I still waiting for the rest. Yeah, some of you already return your draft, right? So after you do your correction, you can send me again. Have you sent me again? Okay, not yet. Okay, sure. So I will wait for your correction. Um, and then yeah, and then we'll talk about midterm later. Okay, good. Okay, so please call your friend to come today. So we're gonna have quiz today. Okay. Right. So let's start lecture first. Okay. How about let's recall what's the definition of being continuous? Okay. Um, maybe 它是昂什么？嗯，伟杰啊，你叫经纬，OK，经纬，按经纬来。What's the definition of being continuous? Maybe one hint, this continuous is called sequential continuity. Something to do with sequence. Check 一下你的 note 呀，找一下什么？大概讲啊，大概来啊，嗯，对，啊，所以你只记到头跟尾巴哦，很 interesting。中间是什么啊？中间很重要。OK，so there are two space 啊。So OK，不要死记，不要死记硬背。OK，你要想象，你要想象这个空间。You have to imagine. Okay, imagine this space here. So what space is happening here? The domain and codomain, right? So you should imagine maybe from R to R. Okay, so you have a function like that. Okay, so continuous is like you can draw without picking, I mean, lift out your pen, right? Okay, so you have a sequence in the domain that converge. Okay, you also will have a sequence that converge in the codomain. Okay, converge to what point? Right, let's say the domain point is P, then the codomain point is FP. Does it make sense? 可以吗？可以记住这张图吗？这张图记出来。Okay, then you turn it into word. So if for every sequence that converge to P in your domain, then if you apply F to this sequence here, also will converge to FP in the codomain. Okay, so this is what we say is that remark here. A continuous function will preserve convergence sequence. Okay, so last time Taylor asked what preserve means, right? So you have a convergence, and then you apply F, that sequence still converge. Does it make sense? Okay, ma? Thank you, ma. Okay. Okay. So then now we can prove one theorem. Okay, maybe I invite you to think about this. Y composite of continuous function are still continuous. Okay. Have you used this somewhere before in calculus? Okay, so meaning if f g, sorry, so if f is continuous at p and g is continuous at fp, then the composition, so which is g compose f. So what's g compose f? So g compose f is just defined by, you need to tell me where you send the point, right? So you do f first, and then you do g. Then g compose f. Or x, okay, is continuous at p. Okay, maybe I'll let you think about 1 minute. How do you apply the definition just now to prove this? Okay, any idea? How to start? Start from where? Where's your domain? Where's your codomain? Okay, sorry, real, right? Okay, okay. I didn't tell you actually, so maybe some domain could be real, could be some other subset of real. Okay, doesn't matter. But then you want to show that it's continuous at P, right? Okay, so previously this definitions is continuous at where? Actually, I should say that this is continuous at P. Okay, because we are looking at sequence that goes to P. So what do you need to do? You need to take a sequence that converges to P, make sure that the function applied to that sequence also converge to the function applied to P. Okay. 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 So how to start? Start is very important. Okay. If you don't know how to start, then you are basically doomed. Okay, so what to start here? Say anything. You need to try. So you don't know, right? You have to try first. You have to hit the wall. I mean, it's not really hit banging the wall, but then you need to try. Right? Definition of continuous. So you need to go back. What's continuous? What do you need to show? For every sequence, you need to show that. How to show this statement? How to prove this statement? You want to show a statement for all, right? What do you need to do? What do you mean I negate? That's this? Okay. Okay, there's one thing I want to tell you guys. So let me think. How should I put it? Okay, in assignments, you write something like this. I already tell you this doesn't make sense. Why doesn't make sense? There's no action here. 没有动作啊，没有动作哎，没有给一个动作，就是动作就是动作，不动动作。也不是咯，都不是，就是没有动作，没有动作就是 I don't know what you are doing。你就有点像有点像什么有点像小孩子在跑东西，你知道吗？跑糖啊，你看那个糖你跟你妈妈讲那个，OK 啦，maybe 你妈妈知道你喜欢糖刚才讲那个还会买给你的，通常你会讲我要那个，对不对？但是有些小孩子就那个，you understand? So what do you want to do here? You want to fix, you want to choose, you want to let. What do you want to do? Or you want to unfix, like what he do? Unfix. I don't know what unfix means. Later, I need to discuss with you this problem. I tell you. Okay. Correct 我 unfix. OK，明白吗？要给一个动作choose fix 什么动作？你要跟我讲，unfix 也是一个动作但是那个 unfix 是错的。OK，明白吗？明白吗？OK，OK。Another thing is for every epsilon 跟 there exists epsilon 一样吗？哦，有没有一个会 imply 另外一个？哦，for every n 跟 for there exists n imply 吗？每个 n 都对了吗？反正肯定有一个 n 有的吗？有吗？不对吗？老板跟你讲你做的很好这个月公司的钱全部是你的，然后你去切一下公司的银行，里面0块钱，有钱吗？而且不一样的这两个东西，
your set might be empty, you know. empty，上次我们讲不是，如果是 empty 的话，那个 segment vigorously true 嘛，for all。that exist 你永远找不到 existence 的，找不到的，you cannot find。understand？明白吗？这两句话不一样啊。OK，明白吗？OK 吗？白谈，明白吗？不一样啊。
Okay, so let's come back here. So okay,
So if you want to show for all, what do you need to show? You need to pick any sequence. Okay, so what do you want to show here?
so your goal is very important. I want to show that.
你看这个字很长哦，很大段哦，你懂要怎样读这个句子吗？懂怎样猜这个句子吗？那句子很长哎。我发现来，maybe Malaysian 啊，不知道你中国人啊，读书是很差的。有没有发现自己读书很差，读不到书了啊，看不懂书了？我给你一本故事书哦，你会读到睡觉了。有没有发现读书很差？我也是很差，其实我是到了差不多 PhD 过后，我才大概 get 到什么叫做故事。因为我看电影会睡觉了，你知道，看不懂，因为他那个心啊跳来跳去，跳来跳去啊。But then 哦，你去看人家解说又看得懂哦，因为他讲好给你听啊，你脑里面不能 process 哦，你懂。So it's very important here. So hopefully this course can help you to organize your thought. OK，so 其实这整句话，这整大段话你要怎样做拆分，你知道吗？
Okay, so first of all, 这样子猜 if 的画一下 then 的画一下 OK 两句话
然后两个 segment，two segments 啊。OK，maybe we look at the then first because this is our goal. OK，so 一个句子里面啊，there should be like 华语叫主语、谓语、宾语，英文叫什么我不知道，subject、predicate 那个什么 something like that。Right，so 主语是什么？所有的 main character 有个的 composition，这个是你的 function，this is the function，and then you want to show that this function is continuous. So this go back to this definition. Function is continuous. So you need to show by definition. So 你要 replace 你的 function with 那个 GF，对吗？这样讲吗？什么名字？对，经纬。OK，good，我记得了，经纬，对吧？Replace
这个 with GF so I want to show that for every sequence that converge to P GF SN converge to GFP OK 吗？OK 吗？OK OK 品杰再问你
want to show a statement for all. What do you need to do?
Good OK so pick one sequence SN converge to P OK so you want to reach that
GFSN to GFP. So now 现在你还可以做吗？我问你，maybe 经纬的后面叫什么？金阳是吧？金阳。OK，so 我已经写出我的 goal 了，我有目标，我会推广的。我要用我的前提，我的 assumption，就是你要证明这东西是有前提的，不是没有东西升到有的。前提，说前提在哪里？我画了两句话嘛，三一句咯，if 要用这个 if 这边有两个东西嘛，对不对？So if f is continuous at p by definition 是什么意思？永顺 F is continuous at P.
The Xn is converged to F.
Yeah, but you need to tell me what is Sn first. 你 definition 只讲一半的，你看这整句话哦，你只卡后半句给我了，有问题耶，这样。如果这后半句有用，我不是把这个丢掉就好了，对吧？你只卡半句话给我，啊，还有什么 ？Sn 从哪里来？还记得我讲过吗 ？Exist 跟 for all 很重要哦。什么
那 P 在左边一点
？Sorry，
那 P 在左边一点
什么？我听不懂啊？他讲什么？听不懂。
他讲 P 在左边一点
不止，哎，这个怎么不讲出来？怎么只讲这句？讲了1.75的东西，为什么差这个0.25不要讲出来？他说讲啊，啊还要讲什么？OK OK， 我画出来，你讲了什么？你只讲了这个 part 吗？这个没有讲。对 ，OK，所以你看啊，我训练你讲哦，你讲的东西都是一般一般的，意思什么？你听我讲话也是一般一般，
你这的
对吗？
的确是大众就没有关系方式，
What do you mean?
没有关系太低啊，最前面
At P, I choose a point. I choose a point P. I choose a point P. This is what it means here. If it's true for all P, then we say that this function is just continue. Okay, so we already fix a P there. Okay, when I say continuous at P, that's the point in the domain. Okay. OK 嘛，明白吗？你注意一下，有没有听人家的话一般一般，很重要啊。
然后要断章取义，不然
对要断
不然
对
挤到太长了。
对，你要断章，但是不要取义。OK， 就是断来看，断出来看。OK， 但是不要乱 interpret， 对吗？明白吗？对吗 ？OK。OK，but then 我们现在有一个 sequence 吗 ？Converge to P, right? So by continuity of F, Fxn converge to Fp. Good. Make sense 吗 ？OK 吗？明白吗 ？OK。下一步呢 ？G is continuous at Fp 哦。回来这边呢，把全部 F 改成 G， 把全部 P 改成 Fp。Right. OK. Can we apply the assumption? Why? Why? Yeah. Then explain more. Why? From this or all here. Explain.
There's a new sequence.
Correct. But the new sequence also converge to F of P. Okay. So it's one of the sequence that converge to Fp. Okay. So again, by continuity of G, maybe I add here since Fsn to Fp is one of the sequence that converge to Fp. So G of Fsn converge to G of Fp. Okay, which we define by G compose F on P.
On the other hand, we also have G compose F with Seng. OK， 明白吗？
You know why I purposely write down this? You know why?
Because there is a potential.
Because this is my function. This is the new function. This is the definition of that function. Okay. Does it make sense? Okay. Although morally it's just this, but then this is a new function. We regard it as a new function. This one, we just regard it on how we apply this function. You understand? Okay, so this is a new function. Okay, if you realize that the function we write down here, I mean in the definition of continuity, right? We write down the function. Okay, it's not how we define the function. It's a function. This function. Does it make sense? Okay, another thing you can observe here is we just have one bracket here. Okay, supposedly we also should have just one bracket. Okay, any question so far? 可以明白吗？可以明白吗？会讲两次，讲两次王者会骂我。对，他讲话太快了，可以讲三句话。重复性的话，你们觉得会比较近的，还是你觉得很烦？我想做一个设备，还是要重要的事要说3遍，还是不可以太快说3遍，3遍要慢一点说。你们的看法是什么？你们喜欢人家重复跟你讲一件事情，还是我觉得很烦？我都知道了，你还跟我讲。一亨，我问一亨来说说看你的看法。你说的，我先问你一个吗？我再问其他的。呀，我先问你一个啊。你喜欢重复？你喜欢重复 ？OK， 好。问天乐看。
如果要共同如果是重复有用方式。
好，有用的他讲。你也是觉得你agree OK？ 好，对，没问题。OK， right， 非常好。So，okay, because everything here, I just use arrow, but do you still remember that we define arrow using the epsilon n definition, right? So maybe I can suggest you one exercise, try and write everything in terms of epsilon n. So what's the technicality between these two? So in the epsilon n case, right, you need to tell me how you choose the n. Yeah, but then it should be obvious. Okay, so maybe one exercise you can do here is exercise. So prove by epsilon n definition. So the technicality involved here is how to choose n or appropriate n. Okay, so throughout the lecture notes, right, there are exercises. So if you in your lecture notes, you try and do these exercises, then you'll get better marks. So your revision not as complete as possible. But then these questions, right, if you're not sure or what, actually you can ask me, right? You can send it to me. Hey, Peggy, have you like finished your correction yet? Why not? No time. Okay, try to finish it. Next week we're gonna have midterm. Hopefully you all can like hand in your revision by this week. Then people can try and read up. Yeah. And then the others, you supposedly should understand what they write. If you don't understand, right, that's mean you are not understanding the content. Okay. It's not that you have to use it for revision, but then when you read it, you should understand what they do. Okay, so for the draft, right, they will send it to me or you will send it to me. And then if I see there's a major correction, right, I will ask you to do the correction first. And then before I post it out. Actually, I posted one already. I posted Huayue one. Have you guys read it? Not yet. Have you found it?
in the Moodle? No, man. I thought I upload already. It's before week 1, I guess. I start a new subject. I mean, yeah. Anyone found it? Eh? Got that. Yeah, here. I will put into this section. Decided to put in one section. Okay. So I posted one from one person. Okay. So I'm still looking from who else? Bai Han, have you start? Not yet. Yeah, quick, huh? Next week is midterm already. If you don't do revision, then it's very hard. So who else? Chen Yu already like waiting for correction, right? Chen Yu here. Chen Yu. Have you like? I think you sent me a draft before, right? Have you like completed? Can you complete by tomorrow? Okay. Okay, tomorrow. Hong Jie not here. Okay, this guy already get removed. Okay, I'll remove him. Jing Han is waiting for correction, right? Have you sent me again? No, yeah. Okay, waiting for correction. Almost done. Cheng Wei not here again. Cheng Wei. So last week was 9 and 10, right? So Xing Yang and Yushen can start handing in already. Yeah. Just send me through email or Teams. Yeah. At the end of the semester, I will create a Moodle link for you guys to submit the final version. Yeah. For now, it's just type up whatever I have in the lecture notes and then make summary, come up with some example questions, and try and make it better along the semester. Okay, so this week is Yuhan and Helen. Yeah. Yuhan is you. Okay. Yeah, good. So maybe we can do announcement now, maybe. So we have a midterm on next week, Friday. So what's the date? The date. 22. Okay, 22 is a good date. 22 May. Let me see my venue. 对吗？有错吗？ Okay. 啊？ What do you mean? Week 7, right? Wait, let me check. Week 7, right? Next week, week 7. No lah. Wait. 22. Okay, so I have to put here Friday. So 2 p.m. to 4 p.m. at A4 105. Why? But then last week, 可是我们上个礼拜我们讨论的时候你没有在，你没有听到，怎样办？可以考2张吗？你同志？你 finance 那个老师是 extra 时间还是 lecture 时间？他几时定？为什么没有跟我讲？又有这个故事发生，是不是没有听？你看听是不是很重要？怎么办呢？怎样赔偿？怎么办？9月？9月？你要先 fail 先。怎么办呢你？想一下， 什么？
星期六大家没有滚，你一讲星期六就我滚你六半夜3点到。
只有 Helen 一个人是吗？两个？你那天没有在我们讨论什么？I never mathematics. What？没有，L 是不会开给你的。两个啊？你们两个啊？早上考要不要？你们 tutorial 是几时？或者你们 tutorial skip 掉了可以考试哦？可以吗？没有，你们不是 OK 吗？OK 啊，可以吗？而且我也会有人看着你们的考试。OK OK，yeah. OK. Another thing is you can bring cheat sheet. Yeah, I won't provide any definition, so you can copy them or example or prove or whatever. But then it's a A4 size. Paper A4 size. Tablet? What do you mean tablet? You want to bring tablet? Okay, so you can bring in cheat sheet A4 size. Okay, whatever you want to copy in is fine, but don't try and be sneaky. Yeah, like put what sticky note or what whatever. Okay, so if we found that, we just remove it. Yeah. Okay, so A4 size mean the usual A4 size blank paper, double sided. Okay, you can do double sided. Okay. Huh? Oh, okay, good. Xing Yang asked about this question, right? What question will come up? Okay. Past year. 我想一下。Okay, so past year you can find from the question in the textbook. Yeah, one of them. Okay, those I have solution. But okay, and then another thing is I asked you to do revision, right? So you guys got pick some question, right? And then do it, right? So if I look at it, I think it's possible. Then I'll release it. So that's mean those kind of question, similar question will come up. Okay. For example, I think Hua Yue got a version, right? Okay, something like that. Okay. Yeah. And then so what's the difficulty? So what's the difficulty? So usually I'll think that maybe let me rank you my difficulty difficulty for assessment. I would think that assignment will be the hardest one. And then sometimes it's exam, sometimes it's tutorial. Will be harder. Okay, so definitely exam will be easier than the assignment. First assignment, I give you time to do. And then you can go and do research. You can check your answer even. Understand? So you have to really score well in your assignment. You can even score full marks actually. So please don't let off this chance. Because exam is the place that you cannot check. You can just write whatever you know. You understand or not? Okay, tutorial, because sometimes we can discuss, right? So we will put a little bit harder questions. Some questions are harder inside them. So require you to think. You understand? Does that make sense? Okay, because exam also you have time limit. So you cannot go too hard. Okay, make sense, ma? Okay. Okay.
OK， 所以就你们两个对吗？之后我们再看一下怎么办。OK， good， yes， 没有 ，OK， 你是 OK， all right， should we do quiz now or later？没有 tomorrow， 因为Helen 会不在是吗？Helen 也不在呀，所以我们 move to 今天。Yeah， 给你5分钟 ，OK， OK 啦 ，we do it end of the lectures 啊 ，we do it end of the lecture。Before the end of lecture， 谢谢。let me see here. Hey, you didn't remind me to discuss assignment 1 eh. I just realized I forget to discuss assignment 1。要，不然你知道你自己在做什么吗？没有错，我知道，我就知道，我知道，因为我学生很 blur 的，不是讲你们啊，就是来，他们不知道他们自己在做什么啊，然后好像没有人给他 feedback 这样啊，自己做错自己不知道的，所以我有时候现在都是很闲，就是。But anyway, never mind. But I will discuss assignment. Okay. Okay. So I guess assignment 1 should be okay lah. I mean question 1, assignment question 1. Okay, I think most of you are doing okay. But hopefully, you guys know to apply in your in your what? Apply in the later course of okay or not, because we're gonna see them. Right. So for example, we already see actually point wise, but not in this case, not in the epsilon delta form yet, in the sequential form. But then later you'll see uniform continuity, Dietrich continuity, and uniform convergence. Okay, in the later case. So now you just see it as some statement, quantifier, like that. Okay, but later on, you'll see them. But then, actually, funny things about some of the people is they don't translate this into English. They just keep this. So they will say that such that blah 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 blah. It's not false lah. It's not false. But then, in this course, I try to make you more precise, more detailed as possible. Okay, so you need to pay very important attention. Okay, to my definitions. Okay, so I define this modulus thing as a distance. So you need to speak in distance when you speak in English, something like that. Okay, does it make sense? Okay. So I take off marks if you don't mention distance when you translate back to English. Okay. 可以吗？明白吗？慧姐明白吗？ OK 哈。Okay. I guess this question 2 actually is I guess is the hardest one. What do you think? You don't know. Okay, you just do it. Okay. How about the rest? Yihan thing is the hardest one. So this question actually have a story one actually. I also think that it's very hard when I was an undergrad. So I went to the lecturers or professor you call, right? Office hour I asked him question 1. So he go and stuck there for 30 seconds. I know, right? 30 minutes. He's the one that asked us to do as an exercise. So I go and ask him, so how to do? I don't know how to do. Okay, at that time I was really weak. I was really weak. I don't even cannot write down mathematically what subset is or whatever, like what I told you. Right? It's very hard. I mean, my first year, I also first year. I was first year. You are guys are second year. Right? I was first year. We first year already do this thing, so I was very shocked. So I think this one is quite hard, but then turns out that what Qi Yang said, yeah, about icon okay. So what Qi Yang said, you just do. I think most of you just do. I can see from assignment, right, you just do. So I think this is a very good trait that I can't see in most of the classroom. Yeah, in this class is very special actually. you just do. Because you have GPT. Okay, maybe you are better generation. You can find GPT. But then there's one case is people don't want to do, even they have GPT. Yeah. So that's worse. Okay, but then I think you can. So this question is kind of tricky. Actually, this question, right, is going to build a natural number that looks like this. Okay. So what you see from this system here is 2 will contain 1. Correct or not? 2. So 1 will contain 0, 2 will contain 1, right? Okay. So this is another way to think about number. Okay. You think of number as greater, right? Because it contains the previous one. Okay? Inside 2, there's maybe 2, 1 there. Okay. So you can think of 2 as a 1 union set containing 1, right? Okay. So they use this way to like distinguish the 2 number 1 inside. Next part is principal mathematical induction actually can imply well ordering. And actually they are equivalent. Okay, you can go back, forward, back and forward. Maybe one of the misconception here is people try to think of this as a finite set. You want to prove that for all n set that with n elements, you can find this one. This is not what this question wanted to answer. This question says that if S is a non-empty set of natural numbers, so it could be already infinite. So if you can prove for all n, what does it mean? It is saying that for each n you can pick, you can find the smallest one. But then this is like I give you infinitely many things. You pick one for me. So this is more than the set with element n. Does it make sense? Okay. If you just show it for every n, every time you are just finite. But then this question include the infinite case. 无限个会解找得到吗？好，给你无限个号码，能够找到最小吗？找不到，不一定找得到的，不一定找得到的。Only when the set is a natural number or positive integer, there's a lower bound. 给你一个 z 的话，你就找不到了。它可以无限下去。Does it make sense? Question 4, I think all of you is fine, but maybe I want to invite you to think about this question in another way, maybe geometry way. Think of it as a geometry way. 有想过吗？有这样子想过吗？ Okay. Okay, for example, assume that a club is students organized. So maybe you have a pool of students, right? And then organized into committee, something like that. Okay. So there are at least 2 students in the club. So the meaning that there are at least 2 points, okay, inside the club. And every committee, so maybe club is a square. Every committee is a collection of 1 or more students. So maybe committee, you can think of it as a line, for example. Yeah, every committee, every line maybe contain 1 or more points. For each pair of students, there is exactly 1 committee who both serve. Meaning what? For every 2 points, in my language, there will be a line joining them. Okay, there will be a line joining them. Yeah. And then no single committee is composed of all the students in the club. So meaning what? No single committee will consist of all the students in the club. So in this case here, you see, there's 1 committee that having these 2 students, or if there's only these 2, then this axiom 3 doesn't make sense, right? So it must be there's another committee. Okay, but then every two of them must have a committee that both serve. Okay. Given any committee and any student not on that committee, given any committee, any student on it, there's exactly one committee on which that student serve, which has no student of the first committee in its membership. 哇，这个东西太长，讲到来我都要先去睡觉先。所以要怎样拆这个句子呢？拆，把它拆开来，怎么拆？谁跟谁在一起？谁在解释谁？找一个知情，来帮我拆个句子，这样怎样理解这个句子？怎么拆？怎么拆呀、我们先大拆先，前半部分跟后半部分给它拆出来。OK，given、一短段，后面一整段。OK，but then 还是很长啊，这个句子。OK，我们先理解一下前半段。Given any committee and any student not on that committee，这句可以理解吗？Pick one committee and 去看一下其他学生不在这 committee 里面。OK， 后面那个是增长，后面那个增长，真的很长，讲真长。OK。There exists exactly one committee on which that students serve. Okay, so there exists exactly one. Okay, so 先把这个改成我们的符号，好不好？这样子，10个字给它换去2个符号。That's a unique one. Committee. Okay， 那我们情况是来呢 ？That one student serve, that the student serve, which has no student of its first committee in its membership. 再读一次。That has this exactly one committee of which that students serve, which has no students of the first committee. First committee 在指谁啊？你是第一个选的那个 committee。OK， 什么？有 idea？ 有 idea？ 说说看，这个行。Okay, so let's pick a committee. Pick a committee and a student not on that committee. 选一个吧，来看一下。There exists exactly one committee on which that student serve. So that student 是在指你选的这个 student. That student 哪个？你选的。Serve which has no student of the first committee. 所以是说什么？它有一个 committee。它有一个 exactly one committee such that has no student of the first committee， 就是说在这条线上面没有前面那个 committee 的学生设在里面。意思说这个 committee 是新的 committee 哦，所以我有一个新的来。Does it make sense? OK 吗 ？So out of these 5 points 啊，我们可以把这张图画出来。Next, every student serve on at least 2 committee. 看一下有没有 ？Every student serve at least 2. So 看一下是不是它全部每个点都至少有2条线，1、2、1、2、1、2、3。Okay. Every committee has at least 2 members. 看看有没有 ？OK， 这个多余的我不要剪。难解释 ，OK。说这个有2个嘛？这个 committee 有没有？这个 committee 有2个嘛？有。这2个 committee 有2个吗？有。But then 蓝色呢？没有。But then 第2个可以从前面的2个来吗？不可以 ，otherwise you will contradict the axiom of five axiom E. Okay, so there's an extra person here. OK 吗？这个是你 argue 的东西啊，我希望你懂你在写什么啊，不是 ChatGPT 告诉你什么是什么啊。OK， 所以回去看一下你答案是不是这样写。OK， so one very good thing is some of the students try to prove the theorem，虽然我没有给你分啊，but then 你去 prove 它就 OK 了。这位，幸好你有回答问题，你有回答问题吗？啊，幸好你有回答问题啊。有些人可能就是 prove 了 theorem 他就结束了，他就收工了。OK，我是没有给这个分数啦，but then 你最好有解这个题目啊。OK，yeah，OK，so it's good that you can try and prove this theorem actually works because you see that these are theorems, right? Theorems is being deduced, right? So make sure, I mean, you can try and prove them. OK，但是我没有给你 extra mark 啦，sorry。OK，Part 5。哦，诶，我讲完了没？我要讲么？还有什么东西要讲？那个prove that there are at least 4 students, right？那不是画给你看了没？解释了一半路了，这已经结束了。Prove that there are four students. I already draw it to you. 4 students. Okay, actually, this is something called the if you know the Euclidean geometry, and you can go and try and check your Euclidean geometry, that 5 axiom to build your Euclidean geometry. That's what Euclid do. Yeah. Right. So very related to that one. Not exactly, but related. Okay. Question 5. Suppose that A and B are positive real numbers such as B squared greater than A squared. Then prove that B greater than A. Okay. So every one of you assume this thing. Okay, everyone assume this thing. But then you need to realize that this course is start from 0. Okay, so you really need to prove this one. Okay, basically you just use distributivity or something like that. Okay, yeah, you need to prove this. If not, I will take off a bit of marks. A bit. Not much, but a bit. And then from this one, I guess it's easy to prove. Yeah. I think most of you do trichotomy law, right? Yeah, trichotomy law. Sorry, trichotomy law. Yeah. Okay. 6. Anyone understand what this 6 says? I think I saw at least 2 different proofs from you guys. Right? 6 says that if you have a set which is non-empty and there's an upper bound for A, suppose further that every open interval I containing alpha intersect A, show that A is a least upper bound. So what's the picture here? So you need to draw your subset. Hi, hello. Suppose that A is not empty and then alpha is an upper bound for A. Okay, suppose further that every open interval I containing A intersect A not empty, show that A is a least upper bound. You know what this means? Can you imagine?
You did draw it all.
I already draw it. Yes, that's right. That's right. I already draw it. No, someone they don't know what I draw. Yeah, there is this kind of person. So, well, no matter what interval you draw, okay, there will be element of A inside there. In particular, you'll be interested in element that's less than A, right? Show that they are not the upper bound. So that this is the least upper bound. Okay, so this is the content of this question. Right. Yeah. Wait, any question? Any questions so far? You guys know what you written down in your solution? Yeah, if not, you can try and ask now. Yes.
The quiz in got two sequence, right?
6, 7, 8, 9. 6, 7, 8, 9. OK， yeah， 有问题吗？还是要 go through 那个 proof 本身吗？有问题吗？ 啊？我忘记你讲不了，忘记你讲不了，你要 check 一下，可以吗？看回去你看得懂你在写什么吗？OK，呀，如果看不懂的话，可以问，我们可以讨论。OK，有问题吗？所以你知道这个第六题的目的在哪里吗？目的在哪里？不止，你要 see more than that。Oh, related to that definition, you mean, right? Yes. So this is a sufficient condition to trigger your definition. 明白吗？ Look, if you compare the least upper bound definition 啊，他没有讲这些东西啊，他没有讲 intersection 的。But then we turn it to another language to talk about it. 明白吗？ So when I ask you to prove a theorem or what, these are the different condition to see the same thing. OK 吗？可以明白吗？所以不要做一个小镇做题家。You know what 小镇做题家？就做吧，我叫你做么就做吧，你不知道自己在做么，对吧？So what I wanted you to do is once you do it, once you prove it，把它放进你的武器库里面，你下次可以用的。什么意思 ？If you have the foundation of the first two statements, you can straight away tell me that, oh, alpha is a least upper bound. I satisfy these two conditions. 明白吗？它是可以用的，考试也可以用的啊，assignment 也可以用的，明白吗？Does it make sense？智慧，听懂我讲什么吗？我讲什么？然后后面部分啊，后面部分关键啊，旁边呢那个会节后一半段是什么？不懂，跳过。子晴后半段是什么？不懂。一黑，因为你朋友挣完了，你也不懂。看到明白了 ？OK，下一个凯泽哈，哎是不是，sorry，文伟是吗？Sorry 啊，文伟哈，OK 好，文伟后半段是什么？Good，这个 tutorial 能用的，assignment 可以用，assignment 可以用的，tutorial 可以用的，考试都可以用。什么意思啊？就是我们有一个先来后到，我们很有礼貌的，先做过东西都可以用，除非 unless 一件事情，我直接问你那一句话，你就要重新证，明白吗？Yes。
差不多有够，什么叫 so that anticipate 到小于 alpha such that
等一下先，OK，等一下先，给我结束我的 flow 先，我再给你 flow，OK 吗？明白吗？OK 啊，听明白吗？我们做过的东西都可以用，在后面的东西，除非我重新问你那整题，你就要从头做，听明白吗？并且 OK 啊，OK，这个很重要。小镇做题家过后，这个东西很重要，因为这个是你可以用的东西，你知道吗？你不用再重新做哦，不然很麻烦的。 哎，冷静点，尊重我一点可以吗？给我讲完，我再尊重你，好不好？
因为
我在讲东西，给我讲完先，我会给你讲话的。啊，明白吗？OK，好，给你讲，来，没问题。
对大小要发小一点，越大。
Thank you。说那个 alpha 其实是什么？不是，人家跟你讲有 contradiction 了，你是不是要改一下？你要改什么？
要发小一点，对大可能 A 小一。
对，没有错，
没事，
不然我这个 S 还什么？对不对？OK，so typo，thank you。Here is a typo。对，没有错，所以你眼睛要放利一点。对，没有错。对，that's why 我眼睛就蒙了。我就很怕 latex 这个东西，你知道吗？你看久看久啊，有一个东西不是你没有注意，你知道吗？你们有读 science 吗？你们有没有读科学？这里的人有一个东西叫做 optical illusion，你知道吗？知道什么叫做 optical illusion 吗？你的大脑骗你啊，因为你大脑觉得那个东西是那个，然后他就把他那个东西看成你想象的那个东西，就有时候会看漏掉。刚才都讲的很像嘛，然后大脑把它认知是一样，真的。我们写 DC 的时候啊，或者写 paper 的时候啊，很长就是几百遍啊，你给另外一个人看又有带过。最重要不要 logic flaw 啦，logic flaw 又很严重了，但是 typo 就还好，logic flaw 很严重就没有办法。但是 typo 一定会出现的，你可以注意一下，你去写你 FIP 啊什么啊 whatever，一定有 typo 的，肯定有啊。你看几百遍啊，你给另外一个人看还是找得出 typo 的，对呀。说你们要小心一点啊，就是要注意这个东西。说呀，也是 typo 的。OK，还有吗？还有问题吗？还有问题吗？好了，不要吵架，不要吵架，不要吵架，不要吵架。可以。
哦，
哪里又有问题啊？
I containing，哪里？题目第二行，I containing。
What's wrong with it?
Sorry about it。
哦，OK，Thank you. Very good. Spelling problem. OK，好，maybe you can 要 break 吗？break，好，let's break。好，OK 了，我觉得 assignment two 我们下次讨论，我们明天再讨论。OK，let's break. Break until 10:16. While break, you can sign in. Sign in. Let me see. I can turn it on or not. Okay, I think you can start signing in. Yeah, you can start signing in.
就以前不是
Yes。哦，等一下，等一下，我再跟你讲。等一下，我跟你讲，等一下我跟你讲。等一下，我跟你讲。等一下。Yes。啊，嗯，对啊，这种你要打出来啊，全部都要打出来啊。然后我画图的意思就是，好像你的这种图啊，呀，这种图可以，你可以去搜一下。drawing graph in latex 有几种方法啊，你可以去试一下哪一个比较方便，比较 yes。可以。不过如果来不及的话，可以先交给我啊，慢慢再填呀。应该都
那个 textbook 里面的题是哪些？
诶，我有放很多本书上去啊，然后我也有放一些答案那边。Oh, another good place to find a question, right, is those example inside the lecture notes. Lecture notes, they are examples, right? Yeah, those are very important also. And then extra is you can go for the textbook. OK，是每次要播一个 video 哈，找到一个 video Oxford 的 Oxford Mathematics。Maybe it's related to you now.
But I think the type of your be consistent with learning to start yourself out because a lot of people, especially like in second year exams, so week 8 and 9. So there's 2 whole months before we start our exam, and people tend to like start really hard, and get to the middle of the time, and they're really tired, and they sort of lose motivation when it comes to the exam. Being very consistent with what you're doing, waking up at a good time, dedicating certain times of the day to having a break.
Over the back, I will go through and I will summarize the course into like a few pages of Word, and I will do it further in one singular with all of the content I need to know to distill the facts of my this. And then once I get back to all of it, it's just what it is.
This is the strategy that I've really recommended. I never really got around to putting it on sheet, but as the goal. Do you do like quizzing yourself on it, or do you just look at it?
I haven't got around to quiz. Mostly the exams.
That's the thing. That's one of the common, not misconceptions, but maybe where people could save time. You might feel like you should go make flashcards for maths, or spend your time rewriting out this sheet. But really, the best way of quizzing yourself and memorizing material is to actually put it in practice, because you end up kind of going through the routine in your head, and you end up pulling up the maths in context. The things with maths is really hard to memorize out of context.
It has the sort of the rhythm of the math. I know these structures go well together. Therefore, I know if I have this first thing, or I know this comes with these bits, and I know these with these, and from there you can sort of build up the proof of just knowing sort of how these behave with each other.
Actually, you disadvantage yourself really if you spend too much time getting into the details. It's a bit of a leap of faith that in the exam, on the day, the pressure, you'll be able to fill in those gaps. At the end of the day, the best revision advice is just crack on. And don't spend too much time watching revision videos on Reels, looking at the person who's watching this video. If you're meant to be revising, go revise.
Okay, we start with quiz. Let's keep everything away. Keep your phone, keep your tablet. Keep your phone, keep your tablet. Okay. I think in assignment 2, I'm not sure you got see my comment or marking like -2 marks on your quiz. I already give back your assignment 2, so later you can check. Some of you you didn't put your name and student ID, then I remark there -2. So okay, this -2 I can give back to you, provided next time you put your name and student ID back. Okay, otherwise your -2 is a forever. Yes. Yes. Okay. Yes. This is a very natural thing to do, right? So you have to do it. So it's like how you do this quiz 3 is the same. Okay. Write down your name, write down your identity, write down what's the subject, okay, of this thing. Okay. So first question, no need to copy. 没有，用 draft 来做你的 paper。So 不用抄，直接回答吧。Okay, so we'll end at 10:26. 分别是多少分？OK。Everyone okay with this rotation? Positive real number. 哪个 positive real number? Epsilon 大于0 basically. 还有问题吗？有问题吗？OK，可以问。重点是你要明白题。 Yes. Okay, maybe I should write like this. So this is defined to be a sequence of absolute value of xn. And in sequence of absolute value of xn. Take it out. Maybe I can give you hint for last question. Hint. 其实这个 hint 是永远都一样。Write down the definition of convergence sequence. OK，你只能够回去 definition 吧。OK，把它写下来，那就很明显。Yes，那个顶住你，sorry，够大吗？definition 写下来。2 more minutes. Okay, time's up. Yeah, write down the last thing. 是吧？还要一次加几分钟啊？2分钟，OK，2分钟。Okay, finish up your word. 2分钟。OK，maybe 恒玉是哪一个？你是恒玉，纯玉是另外一个，你是纯玉吗？你叫什么？张恒玉哦，他是叫张恒玉，你是纯玉是吗？OK，好，那从恒玉开始收啊，可以帮我收吗？收一下，23分应该慢慢算一下有没有？We won't mark this in class. We'll continue with lecture first. We'll discuss this quiz later. Okay. Let's continue with lecture. Okay. So far we have upshot. Okay. How to build 23分，可以帮我算一下吗？24分。How to build a new continuous function from the old one. Okay. Do you still remember? We can take sum, scalar multiple, product, quotient, and also the latest one, composition. Okay. Basically, it's the limit law, right? Limit law. Okay. 好吧，还在上。看，对啊，OK。哦，不用，今天不用来。Okay. Next, we come into a very important theorem in analysis, which is called the intermediate value theorem. Okay. So from this name, what do you mean by intermediate? You know what is intermediate? Huh? Median. Might not be median. Median is very precise, or you know, median is like the middle one.
Intermediate is something in between. 之间就好，两个号码之间。Okay, median is like kind of 中 yeah. Okay. So suppose that f is a continuous function. Okay, must be continuous. On the closed and bounded interval, this is very important. Closed and bounded. Again, closed and bounded. Okay. Later on, you'll see this as a compact property, but then not in this course. Let's say you have some value in between FA and FB. From here, you should have picture in your mind already. You know what picture you should draw in your mind? There's a F, there's a closed bounded interval, there's a FA, FB. Okay, so something in your mind should be something like this. There's a AB here, okay, and then there's a FA, and then there's a FB, right? Okay, maybe I need to draw it a bit different. So FB greater than FA. So if there are some number in between these two numbers, so let's say Q here. Okay, so maybe let's draw FA here, FB here. Okay, then there exists a point in AB such that fx equals to q. What does that mean? That means this function will attain this fq here. Oh, sorry, attain this q here by some x. Intermediate value theorem. So I can hit all the value in the middle. Not middle lah, in between. Okay, middle is very precise term. Okay, in between this. Make sense? Okay, so that's why people will think of continuous as drawing without lifting the paper, because you can get any number, okay, in between these two values, and even you are close from the intent. Okay, but close and bounded is very important. Now later I'll give you an example where this theorem will go wrong if it is not close and bounded. Okay, how to prove this statement? You want to get an existence statement, right? So one is you go and find it. Two is just say that it exists. We have this kind of statement, right? For example, completeness axiom. I didn't tell you what is the least upper bound. I just tell you that if it is bounded above, then it has a least upper bound. I didn't tell you what is the least upper bound. Exists. Okay. So we're gonna use that trick. Okay, so there are two proofs actually. In my notes, there are two proofs. So I'll present a proof using completeness of R. Use completeness. Okay, so in that case, we need to have a bounded above set. Okay, so what's the set we want to look for? So let's consider this set here. Okay, you look at all the points in AB such that fx is less than or equals to q. Okay. So we claim that the supremum of this will give us the point we want. And then the supremum of this set should live inside the closed bounded interval AB. Okay, so meaning this x here is the sup of this thing. Okay, so maybe I'll tell you our goal first, then we will work toward this goal. So our claim is f of sup A equals to q. What do you mean why? 我要证。我能证明对，现在等一下。现在可以。对，我现在。什么在点？如果 F 是平静的话，你就讲真。啊 ，OK， good question，good question，good question， OK，good question，good question。可以 keep 住你的问题，然后看一下我的 proof。可以 keep 住你的问题。 Okay. For now, okay or not? Okay 吗？懂我在做什么吗？这个 set。I look at all the point in x such that fx is less than equal to q. OK， 明白？明白吗？俊伟是吗？这个 set 在做什么 ？I look for the point in the domain, and then I evaluate fx， 看一下它是不是小于等于 q。是的话，我把它放进来这个 set。OK， then I claim that there's a supremum here, and then this supremum evaluate to q. I need to prove out two things. 我要证，我还没有证给你看 ，but then 我讲有。OK， 现在我跟他证。So to prove supremum A exists, what do you need to have? Two things, right? Non-empty and bounded. Okay. So why is it non-empty? Because I have A and B. Does B satisfy or not? Does B satisfy? FB is strictly greater than Q. So B doesn't satisfy actually. But A satisfy, right? Because FA less than Q. Okay, so that means what? A is non-empty because there's A inside there, little a. Thing A is in A because fx is less than q. Okay, there's at least one thing inside there. Your left endpoint inside there already. Moreover, it is bounded above. Bounded above by who? This set is bounded above or why? It is actually a subset of a closed bounded interval. 对吗？你最多也只能够选到 B 嘛。So it's bounded above by B. Make sense? Okay, so far? Okay, so then, therefore, sup A exists easily. Okay, so by completeness axiom. Sup A exists. But 你可以问一个问题哦。You can ask a question actually. Sup A, is it possible live outside the set? Sup A 有可能跑出去嘛？跑出这个 closed bounded interval 有可能吗？ Why? Sure, but then we need to prove it. So you want to show that it is inside this interval, right? What do you need to show? You have to show that sup A is greater or equals to A and less than equals to B. Okay, so I think first one is obvious, right? Because sup A is a upper bound. How about the second one? Right, how about the second one? Huh? Suppose as this? What? Sup A is a least upper bound. So no suppose is already least upper bound. Treatment of the closed interval. Yeah, and then so how do you compare sup A and B? Just now we said that it's bounded above by B, right? So meaning B is an upper bound. But then this is the least upper bound. I think you use this in your assignment too, right? So least about upper bound should be less than any upper bound. Okay, because sup A is a least upper bound. OK， 不要纠结，不要纠结，冷静一点，听我讲完先。不要纠结，先听先，我会讲给你听，那你不要怕，我不会骗你的。Yeah，OK， 可以吗 ？Make sense？ OK， so to show that something is inside the interval， 就是说这个 inequality 分，没有什么很奇怪的事情。OK， now I think let me see. Okay, so maybe we can make a further conclusion. So a further conclusion is actually sup A is attainable.
So in the closed interval AB, right, meaning it is a sum number. 它是一个号码来的。Okay, sum number between A and B, which means if your least upper bound is attainable, meaning that it is a, which means it is a maximum. Okay, it's a maximum of A. It's a maximum of A. Okay, it's a maximum of A. OK 吗 ？maximum of A， yeah， 它是里面最大的，它在里面。Okay, so finally we go to a question by Chiang. So lastly, we show that f of sub A must be Q. Okay, so you want to show these two things equals, right? You want to show two things equal, you need to show less than or equals to and greater or equal to, right? Okay. So well, by the set condition, right? Automatically we know that f of sub A is less than or equal to Q. Okay. So what do we left to show here? So we just need to show that the other possibility is not possible. So which means I cannot have f of sub A strictly less than Q. Okay, we're going to show that this is not possible. It's not possible. It's impossible. I think something wrong in my notes. I said it's not impossible. Double negation. Okay, it's not possible. Okay, so how are we going to show this? Okay, how are we going to show this? Okay, maybe put some picture here is nicer. So we have A, we have B. My sub A maybe inside here. Okay, now we do some clever thing here. Maybe let me construct first, then we can discuss why we do this. So let me construct a sequence, yn, which is a minimum of B or sub A plus 1 over n. Okay.
So what am I doing here? So I'm kind of like approaching here. No, actually approaching sub A. Because 1 over n, if you take limit to infinity, this is getting close to sub A, right? Okay, but then you take minimum of these two. So let's say sub A is here. Okay, so maybe sub A plus 1 is here. Again, then the minimum one is B. And then I take closer, 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 and closer. Sense? And so that this sequence will not jump outside the closed bounded interval of AB. Does that make sense? Do you still remember we have a result on a sequence in closed bounded interval? Sequence in closed bounded interval. What happened? Nested. Yeah, nested, sure. Another one. There one need a nested interval, but then I don't think this interval is nested. Huh? Converges, man? Who converges on? The sequence must converge, man? Yes, it contains a convergent subsequence. What's the name? What's the name? Very important name. Very cool name. Okay. So let's see we're gonna use this or not. Okay, never mind. I think we're not using that. Okay. Okay. So it is clear that for every n, we have yn greater than sub A. Correct or not? Because sub A plus 1 over n.
So what does that mean? These are the upper bound, no upper bound. These are the point that are not in A. Okay. So in particular, this sequence, right, should evaluate to something greater than Q. Okay, otherwise it will stay inside A. Okay, but since F is continuous, as Yn converge to sub A, meaning what? Implies that the Fyn that's greater than Q, which are greater than Q, will converge to F of sub A. Correct or not? Preserve convergence. But then this sub A or F of sub A, we assume it is less than or equals to Q. Okay, therefore, it can only be Q. So maybe you will notice here why I can throw the less than away. So maybe one lemma, you should think about it. So one lemma, you can think about it. I think this is very similar to our assignment 2 question. So if you have something strictly greater than Q, okay, there's a sequence that's strictly greater than Q, and you try to converge to something that's less than or equal to Q, it can only be the case that L equals to Q. Otherwise, if it converts to something less than Q, then there will be an epsilon gap that you cannot achieve on. And there will be an epsilon gap. Does it make sense? 有一个大于0的东西，把你要 convert 出一个小于等于0，有可能吗？全部东西大于0啊，你可以 convert 出一个 negative 号码吗 ？For example, okay, so let's say 0. So all your point is above 0. Can you convert to something negative? You can think about this epsilon gap here that you cannot achieve actually. Try and write the argument down. Okay. Yeah. So the only case is it must converge to something equal to Q.
Okay, let's say you also know that it converges to some limit. Then let's go.
Does it make sense? 问题吗？有问题吗？ No. Okay. Yeah.
可以看到这个例子吗？ Okay, if you know that it converges to something less or equal to 0, you cannot go to -1 because there's no point, no sequence, okay, no term in between the section.
Okay. Actually, just now I point out the Bolzano-Walsh theorem, right? Actually, you can use that as a second way to prove it. Okay, it turns out that this is enough for now. Okay. Similarly, you can change this statement
To FA greater than Q greater than B.
so you can go the other side.
Okay, it's similar. It's a similar case.
Does it make sense? 可以吗？可以明白吗？ So you can turn this intermediate value theorem to the other case where it is F, let's say here, FA greater than Q greater than FB. Okay, you can prove this case. Okay, you can do as an exercise. Okay 吗 ？Okay， 问题来。Yes。有问题吗？
那个这个虽然这个数值你的比例本就不能去问我。就是你写 F 小于 F 上，
对，我选了呀，我选。
它是讲一个 number between F A and F B， 所以这个只是一个比较。
然后我有画这个蓝色的，你有注意听吗？Okay, I mean like this is our convention.
把它那个提问的名字不就一个
哦，你是纠结的事情啊，你是纠结，你是纠结的事情。OK，maybe we take this convention 哦，啊，名字呀，那就这样就这样，OK，对，
就是名字问题吧。
对，就名字问题。OK OK，好，对，差不多。OK，对，so from this intermediate value theorem, right, you can prove the other direction. Okay, where FB greater than Q greater than FA.
Yeah.
Then in this case, yeah, similar proof. Yeah, you can write down a similar proof. Then you will achieve what the usual intermediate value theorem that you search up in internet, is it? Yeah. That's right. Okay. 赶时间啊，并且。Okay. Any other question? 大家问题吗？ OK，还有其他问题吗？没有。OK， then in that case, we will continue tomorrow. OK， 要走吗？不想走。我 continue tomorrow. OK。哦，可以跟你讨论那个 unfixed 这东西。其实我不知道你的想法，但是我可以跟你讲我的想法先。我讲我的想法先，然后你再讲你的想法。可以，没有问题。我先讲我的想法，因为 OK， 等下再跟你讲。